solve and graph the inequalities. All right, so we have 3 into 3x minus 4, which is less than or equal to 2x minus 5. All right, so what we're going to do, we're going to take this, so it's 3 into 3x minus 4, which is less than or equal to 2x minus 5. So what we're about to do is that we want to distribute that 3 inside. So what we have is 9x minus 12, and this is less than or equal to 2x minus 5. All right, we're trying to solve. So what we want to do is to collect our x's on one side of the equation. So what I'm going to do is I'm going to subtract 2x. And the reason why I'm subtracting 2x is because it's a positive 2x on the right. So I'm subtracting that and balance the equation by subtracting 2x from the left. Let us simplify this. Now 9x minus 2x will give me 7x here. I still have my minus 12, and this is less than or equal to, this becomes 0, but we have negative 5. We're adding 12 here. So this becomes a 0, so I'm going to be adding 12 here as well. So what I basically have is 7x, which is less than or equal to 7, because a negative 5 plus 12 gives 7. Then I'm going to divide throughout by 7. So 1. So x is less than or equal to 1. So that is the solution region where x is less than or equal to 1. What I'm going to do after this is I'm going to represent this on my number line. Now, if you don't know, let's do a quick thing on the number line. Now, if I have a bar under any one of my inequality, I'm going to represent that with a solid circle. But if I have no bars underneath them, I'll use unshaded circle there. So in this case, you do notice that there's a bar underneath my inequality. So I'm going to go where number 1 is, and I'm going to have a closed circle here. So I'm going to shade at number 1. What this really means, it's telling you that number 1 is a part of the solution. So remember, we are graphing on our number line where x is less than or equal to 1. So I'm going to point in the direction numbers that are less than 1. So I'm going to point that way. And so that's the representation on the number line of my inequality. Let's go for another question. You are making wooden picture frames of different size, but you have limited supplies. So you are restricting the perimeter of the frame to 4 feet or less. All right. The length has to be exactly 1.5 feet. Find the range of the frame's width. Show working. Let's take a quick look at what we got. A diagram would work. Here is a nice diagram. Now, if I must have this has to be 1.5. So that's the length. This is also 1.5. Now, what I could do, though, is I could simply let this be called x, right? We could let the width be called x. So I could set up a system, let it equal to or less than 4, and then solve, because here it is that we could say 1.5 plus 1.5 plus x must be less than, we were told that that's the largest we could have. So it's going to be 3 plus 2x is less than or equal to 4. Let us subtract 3 from both sides. So we're going to have 2x, which is less than or equal to 1. And then we're going to divide both sides by 2. So we have it here that x must be less than or equal to a half. And that's what we're suggesting. That is our width. It has to be less than or equal to a half to satisfy the conditions in this question. Let's take a look at another question. Yeah, so this question and number 3, it says here a lawn cutting service offers 2 monthly plans. Plan A is that we have $15 per lawn cutting plus a flat rate of $20 per month. Plan B, we have $25 per lawn cutting. Write an inequality to determine the cost of cutting X lawns using Plan A is less than the cost of cutting using Plan B. All right. So the cost of cutting Plan A will be less than cutting, less than the plan for cutting Plan B. Now let's take a look at what Plan A is. You go back here. We're dealing with X lawns, okay? So it's $15 per lawn. So Plan A, we're dealing with $15 per lawn. So that is 15 times X. Plus there is a flat fee of $20 for that one. So that is the idea for Plan A's service. For Plan B, we're looking at just $25 per lawn. Okay. Now we want to write an inequality where Plan A is less than. Okay. So Plan A, which is 15x plus 20, less than 25x. And that's it. That's it. Our Plan A is less than what we have for the Plan B. And we're done with that. Let's take a look at question 4, equality here. So basically, an inequality is solved just as though we solve an equation, unless we're multiplying or dividing by a negative number, we flip our signs. But let's see what we're dealing with straight up. So what we have here is we're collecting our like terms, because if you look on my left side, we could collect our like terms there. So we're dealing with this and this. We could just merge them. If you want to write them beside each other first before we make the move, that is that. It's going to give us a negative 1.2x plus 0.85, and this is less than 8.65. What we're going to do here is that we're going to subtract 0.85 from both sides. And let's write back what we have. We're still going to have our negative 1.2x. This part becomes 0, and then we have less than 7.8. Now, at this moment, we are about to divide by negative 1.2. So because we're going to divide by a negative number, our sign will flip. So as you can see, that sign will now flip from less than to greater than, dividing by 1.2. So x is going to equal to negative 6.5. So x is greater than negative 6.5. And that is our answer for that one. About inequalities, so the perimeter P would be the distance along the boundary of this triangle. So basically, if we're setting up that 2x plus 5 plus x plus 13, that is less than 21, but it's greater than or equal to 18. So basically, we're taking this and we're representing the perimeter where P is. Let us simplify this. So basically, I have my 18, which is less than or equal to, so this is 2x and x, that becomes 3x. 5 and 13 becomes plus 18. This is less than 21. Let us subtract 18 from both sides. So we'll minus 18 throughout, should say. Minus 18 throughout. So we're going to minus 18 here. We're going to minus 18 there. So what we're looking at is 0 here, greater than. So the 0 is less than or equal to 3x, which is less than 3. And then we divide throughout by 3. So 0 is less than or equal to x, because this becomes 1. So it's 1x less than 1. So these are the range of numbers that we have to use, right? Are these values viable in this situation? In other words, can we have these as side because x, one of the side is x, as you can see here. So one of the side is actually x. The issue is 0. So I can't have a side that is 0. That means the triangle wouldn't exist. So, but let us check though. Let us check if we could make a triangle from this. So let us say we have 1. This is 1. This becomes 7. Okay. All right. So when we check substituting 1, I'm substituting the largest value here, which is 1. I do realize that we're going to have a problem in context, meaning that not all numbers can make a triangle. So the triangle inequality theorem would suggest that if I add any two sides, it must be greater than the third side. So look at this. If I add 1 and 7, it is not greater than, we could see that it's not, it is actually less than 13. And because we have that, then this cannot be a triangle. So we can't have 1, and definitely we can't have 0. So anything between 0 to 1 will not make a possible triangle based on the triangle inequality theorem. So no, these answers are not viable for the context. All right, let's talk about situation 6. So the sixth question here, and last, it says, write a compound inequality for the graph below. Interpret the inequality in terms of the range of students' grades in the last math exam. So I'm going to write my compound inequality. So I'm going to say, okay, so we want to show that x is less than or equal to 90, but greater than or equal to 50. So let me put this on in terms of the graph. Let me graph this. So I'll go like this, and I go like this. So what this is suggesting here is that the students would have scored from 50 all the way up to 90, which means that we have students that got 50, and we have students that got between that up to 90. So the lowest score was a 50, and the highest score was a 90 on this test. See you next time. DellyMaths Concept, Algebra 1. Bye-bye.